The last couple of examples we're going to look at are going to be some actual real life situations, but it's still going to be working with the same formulas. All right, so this first example, as it states, a cable railway is driven by a 13-foot diameter drum that turns at a rate of 18 revolutions per minute. Find the speed of the cable car in miles per hour. Okay, first of all, you're asked for speed. So you would need to know that that means you're finding V, okay? Remember how fast something is moving around the edge of the circle. And I mean, just think about the units that we have had on all these other problems where we have found V. It's been miles per hour, or it's been, feet per second. Of course, it states that it wants you to find this speed in miles per hour. So it doesn't just flat come out and say find V. You've got to understand that that would mean speed, okay? Now, the formula that you're going to end up using here is going to be V is equal to R times omega. You have R not directly, but you're told that the diameter of the drum, of course, I guess I should explain this first. The cable railway that's driven by this diameter, this 13-foot diameter drum, this is a circular shape, okay? And don't get bogged down in these problems with understanding the mechanics or how the mechanical part of this is. All of this is going to be based on something that's circular, okay? But if you're given diameter to be 13, then you can get from that, obviously, radius by taking half of it. Okay, so we're going to know that our radius is 6.5 feet. Okay, now omega, you know omega, because remember revolutions per minute is an angular velocity. I've already explained that on 2 other problems. So omega is 18 revolutions per minute. Now I do need it to be radians per minute. Again, you can go ahead and change it now or wait and just change it in the problem. That's what I'm going to do. So we have R and omega ready to plug into the formula here. Okay, so R is 6.5 feet. And you multiply that times omega, which is 18 revolutions per minute. Okay, couple things we've got to deal with here. First of all is we've got to get rid of the revolutions. So let me go ahead and do that. So 1 revolution is equivalent to 2 pi radians. Now another situation that, or 2 other situations we've got to deal with on this particular problem is the fact that they want this in miles per hour. And right now what I'm going to get is feet per minute. So I've got 2 more conversions I've got to do. I've got to deal with the feet and the miles. Okay, so let's do that first. So knowing how many feet are in a mile, that's 5,280, okay? So 5,280 in 1 mile. Now you would want to set it up where the miles is on the top, because you're wanting your answer to have only miles in it, which means you need the feet to cancel. So if this feet's in the top, you got to put that feet in the bottom in order to get them to cancel, okay? Now you're also wanting this to be in hours, which means you need to get rid of the minutes. So of course we know that there's 60 minutes in an hour, but if I want to cancel the minutes out, I've got to put the 60 minutes on the top and the 1 hour needs to go to the bottom, okay? So let's go through and cancel out what we've got here. Okay, so I've got the feet cancel, the revolutions cancel, the minutes cancel, and of course this is that situation where you're just going to pretend, the radians is not even there. All right, so let's multiply what we've got here. So I'm going to have to do 6.5 times the 18 times the 2 pi times 60. And then we need to divide that by 5,280. Okay, so that's going to be about 8.35. I'll keep a couple of decimal places and see I'm left with miles on the top and hours on the bottom. Of course, you can put the slash if you want to, but you've got the abbreviation there for miles per hour if you want to do that too. Okay, so that one had several conversions you had to deal with there. The next one, all right, a ski lift is being designed. The wire rope needs to travel with a linear velocity of 2 meters per second. All right, let's go ahead and write that down. We know linear velocity is 2 meters per second, okay? And you have an angular velocity of the bull wheel needs to be 10 revolutions per minute. So angular velocity is 10 revolutions per minute, okay? So what diameter bull wheel should be used? Now, if you're wanting diameter, what you're going to end up having to find is actually going to be radius. That's what you're actually going to have to find, but then just take your answer and double it, obviously, to get your diameter, because none of our formulas directly give you diameter. Okay, so we know linear velocity, we know angular velocity, and we're trying to find R. Okay, so what we're going to deal with, our formula, is the V equals R times omega. Okay, now if you want to go ahead and get R on one side by itself, you can. Of course, that's going to end up giving you a fraction to work with. I think I'm just going to leave my formula this time and plug in my information. Let's just do that. Okay, so for V, I have 2 meters per second. And that's equal to R times, of course, omega is 10 revolutions per minute. Okay. All right. Actually, I think what I'm going to do right here, and like I said, there's more than one way to deal with this. I'm going to go ahead and get R on one side by itself before I start bothering with any conversions. Now, this is just a number, so if I want R by itself, that means I'm going to have to multiply both sides by its reciprocal. So same thing over here. So see, this cancels, all that cancels out, see, which gives you your R by itself. Okay, so what I have right now, I have the 2 meters per second times, of course that's like 1 minute, but 1 minute divided by 10 revolutions, okay? Now, let's talk about the conversions that we've got to take care of. So you've got the revolutions per minute, so let's go ahead and take care of that conversion. Now, because of me having to multiply by the reciprocal this time, the revolutions has ended up on the bottom, so you need to put the 1 revolution on the top and the 2 pi radians on the bottom so that you can get those to cancel out, okay? The other issue is the time. I need these to cancel out, both of them to cancel, because if I'm finding radius doesn't involve time at all. So I need to get minutes and seconds to cancel, so we know there's 60 seconds in 1 minute, but you would need to put the minute on the bottom and the 60 seconds on the top. See, that will put, so where the minutes will cancel out, and that'll put the seconds. Okay, so I think that's everything I gotta multiply by. So minutes cancel, seconds cancel, revolutions cancel, and you remember you get to ignore the radians if you don't need it. So the only unit I've got left is just the meters, which makes sense when you're dealing with finding radius, okay? So if you do your 60 times your 2, and then divide that by 2 pi radians. Now, as far as an exact answer, you're going to get 6 over pi, so that would be 6 over pi meters, which would be equivalent, of course you can put it in your calculator, 1.91, and that would be meters. Okay, so I've worked several examples here that have had lots of conversions in them. You're not going to have to convert on every single problem, but I wanted to do several examples where you could see that. So don't forget to do those if you need